8-1, adding and subtracting polynomials. So our objective in this section is to classify, add, and then subtract polynomials. And we can use something called monomials to form larger expressions called polynomials. Polynomials can then be added or subtracted. Okay? So in this section and in the subsequent chapter, we're going to talk a lot about different ways that polynomials interact, and then we'll get into factoring. Okay, but first we have to know what a polynomial is. And the way we do that is we first break it into pieces called monomials. Monomial is a real number, a variable, or a product of a real number and one or more variables with whole number exponents. Some examples of monomials. 18 is a monomial. It's one term. And that's kind of what monomial means. Mono means one single term. Okay. Z is one single term, and you would think that maybe that's two terms, but it's not. It's one term together. Okay, we define monomials as products. If you see addition or subtraction, that is no longer a monomial, right? We don't see sum, we don't see difference up there. Okay, so as long as it's one thing all multiplied together, or like a over 3 divided, it is a monomial. And we can classify monomials first with something called degree. And the degree of a monomial is the sum of the exponents of its variables. The degree of a non-zero constant, like 18, is 0. And then 0 has no degree. Okay, that's undefined. Okay, so to find a degree of a monomial, we only look at the exponents of the variables. So 5x has a degree of 1. Okay? 6x to the third y squared, that has a degree of 5. 3 and 2. And then 4 has a degree 0. There is no variable. Okay? Or you can say that there is a variable, it's just raised to the 0 power. All right, let's try a few got it problems, see if we got the hang of this. 8xy, the degree of that would be 2. Negative 7y to the fourth z, the degree of that would be 5. And 11, the degree of that is 0. Okay, so we just look at the variables and we add up all the variables to find the degree of the monomial. Okay, so then we can add or subtract monomials by adding or subtracting like terms. So as long as the variables are the same, exactly the same, all of the variables, we can combine the coefficients. Okay, so the sum or the difference. We first look and see, are these two like terms? They're both x squared. So they are like terms. So 3x squared and 5x squared give me 8x squared. Okay. We look at the variables in part B and we say, are they exactly the same? It's x to the third y. They're both exactly the same. So that's a 4. Remember, that's a 1. So if I were to subtract them, I get 3x to the third y. Remember, when we're combining like terms, the variables do not change. Okay. Some got it problems? Oops. The sum of negative 6x to the fourth and 11x gives me 5x to the fourth. And I make sure these are exactly the same. X squared y to the fourth, they are, and 2 minus 7 is negative 5. It's okay if it's negative. Okay? It's just negative 5 x squared y to the fourth. Okay? Next, we have something called polynomials. A polynomial is a monomial or a sum of monomials. And poly, unlike monomial, poly means many. So we're talking about more than one, or one if it is a monomial. So the following polynomial is the sum of the monomial, 3x to the fourth, 5x squared, minus 7x, and 1. And you can see that all the variables are different. They all have different degrees, right? That's degree 4, 2, 1, and 0. And none of them are like terms, so none of them then can go together. The polynomial shown above is in standard form. Standard form of a polynomial means that the degree of the monomial terms decrease from left to right, biggest first, all the way down to the smallest. The degree of a polynomial in one variable, and that's pretty much what we're going to focus on in this chapter. So we're going to focus on polynomials with one variable, is the same as the degree of the monomial with the greatest exponent. So the degree of this polynomial with these four terms would be 4, because that is the degree of the biggest term. Okay. Now, we have special names for polynomial with different degree. So we can name a polynomial based on its degree and the number of monomials that it contains. And this is going to be the degree of the largest term. So if the degree is 0, it's called a constant. If the degree is 1, linear, 2, quadratic, 3, cubic. And there's special names for 4 and 5, quartic and quintic, but for the purpose of this section, we'll stop at 3. Anything bigger than 3, you just call 4th degree, 5th degree, 6th degree, whatever. Okay. Then, once we name the polynomial by degree, we also name it by the number of terms. 1 term, monomial. 2 terms, binomial. 3 terms, trinomial, right? Bi means 2, like bicycle. Tri means 3, like tricycle. Okay. And, right, the next two both have 1 term, 3 terms, monomial, trinomial. Okay. So each polynomial is going to get 2 names. One of these, and then one of those. Okay, a first name and a last name, if you want to think of it like that. Okay, degree, then the number of terms. Okay. So write each polynomial in standard form. Then, what is the name of the polynomial based on its degree and number of terms? So we can't put these two monomials together, but they're still not in standard form yet. What we need to do is we need to make them the biggest exponent first, down to the smallest. Then we can name it. Looking back at our, well, first of all, this is degree 2, that's degree 1. There's 2 terms. Looking back at our chart, that would be quadratic binomial. So this is a quadratic binomial. Okay. Let's do the second one. Order first, then put the like terms together. So here's the biggest degree. So that's 5x to the third. Then I have a 4x and I have a 7x. So those two can go together to give me 11x and then minus 1. Okay. Now this has 3 terms. That's the biggest degree, which is 3. So this is degree 3 with 3 terms, which is a cubic trinomial. Okay. Name it by degree first, the number of terms. Okay, let's try a gotta problem. So 2x minus 3 plus 8x squared in standard form. Nothing can go together, nothing can go together, and we have 8x squared plus 2x minus 3. Okay? That is the biggest degree. Quadratic. 1, 2, 3 terms. Trinomial. And how does writing the polynomial in standard form help you to name it? Well, if you write it in standard form, the largest degree is first, so that prevents me from making a mistake about what is the biggest degree. Okay? We can add polynomials by adding the like terms, and I think we've seen this a little bit, but when we add complex polynomials, right, sometimes they're going to have more than one thing that goes together. And we'll put it together in a nice word problem here. So a researcher studied the number of overnight stays in U.S. National Park Service campgrounds and in the backcountry of the national park system over a 5-year period. The researcher modeled the results in thousands with the following polynomials. Campground polynomial, backcountry polynomial. In each polynomial, x equals 0 corresponds to the first year in the 5-year period. What polynomial models the total number of overnight stays in both campgrounds and backcountry? So basically, if I want to know the polynomial that represents everybody camping in both of these places, I'm going to take the campgrounds and I'm going to add them to the backcountry. And there we go. Okay, so that's going to be negative 7.1 x squared minus 180 x plus 5,800 plus the backcountry polynomial, 21x squared minus 140x plus 1900. Okay? So, combining these, I can combine the like terms. So this one goes with this one, which gives me 13.9x squared minus 180 minus 140 gives me a minus 320x. 5,800, 1900 gives me a positive 7,700. And there's my polynomial for the total number of people who stay in the campgrounds and the backcountry. Okay? Same idea with our got it problem here. A nutritionist studied US consumption of carrots and celery and broccoli. All very good. Eats lots of vegetables. Over a 6-year period, the nutritionist modeled the result in millions of pounds with the following polynomials. Carrots and celery, there we go. Broccoli is the next one. And I'm going to guess we're going to add them together. Carrots, celery, and broccoli all together. So we do carrots and celery minus 12x to the third plus 106x squared minus 241x plus 4477 plus my broccoli, 14x squared minus 14x plus 1545. Okay, so now in this one, the broccoli polynomial has no x to the third power, so the negative 12x to the third can't add with anything, so it's just going to stay the same. 106 and 14 gives me 120 x squared minus 241 and minus 14. That gives me negative 255 x and 4477 plus 1545 gives me 6022 for my polynomial. Pretty simple. We just want to make sure that the same variables add to the same term, like terms, right? Like terms combined with other like terms. Now, for subtraction, it can get a little confusing. So just recall The subtraction means to add the opposite. So when you subtract the polynomial, change each of the terms to its opposite, and then add the coefficients. Okay? And what we're really doing is we're kind of going to distribute this negative sign right here to the polynomial behind it. Okay? So here's what we do. We go x to the third minus 3x squared plus 5x. Now, to add, or sorry, to subtract the polynomials, I'm going to add the opposite. So I'm going to put a plus. I want the opposite of 7x to the third. So that's a minus 7x to the third. The opposite of a positive 5x squared, that's a minus 5x squared. The opposite of a minus 12 is a positive 12. Okay? And then here, I didn't really have to do that. I could have just combined this. I could have just left this as a minus instead of a plus. Okay? Now, I just need to make sure that I combine the same thing. And we see we have a positive. We just distributed the negative to all three terms. That becomes negative, that becomes negative, and the last term, a negative times a negative, turns into a positive. So this turns into negative 6x to the third minus 8x squared. The second term has no x, so we just have a 5x and a 12. Okay. For our got it problem, we're going to go minus 4m to the third minus m plus 9, distributing the negative, changing the sign of each one of the terms in the second thing. We get a minus 4m squared minus m plus 12. Okay, by far the biggest mistake people make with subtraction of polynomials is they only subtract the first thing and not the other two. All right, so there's no other m to the third, so it's 4m to the third. No other m squared, so we got a minus 4m squared. We got a minus m and a minus m, so it's minus 2m. And a 9 and a 12 to give me 21. Okay. So the degree, that's degree 4. That's degree 5. Some are different. Just add or subtract. Let's do these real quick. That's 11r to the third plus 11. This one would be x squared minus 3x minus 7. Okay? Right? Because we're turning this into minus 3x minus 5. Name each polynomial based on its degree. This is a quadratic trinomial. This is a linear binomial. Okay, degree first, the biggest degree, and then we check the number of terms. How are the processes of adding monomials and adding polynomials alike? Well, we just look for the like terms and we're going to put them together. How are they different? Polynomials are going to have more than one term, so we just need to make sure that we're adding all the things that are like together. And that was 8-1, adding and subtracting polynomials.